Hello, Mr. Kowalik here again. Today we're going to be finishing up part 3 of the Sedimentary Rocks presentations. I'm going to talk about the second half of the reference table and how the rest of the sedimentary rocks form. So make sure you follow along with your notes, and you're answering the questions, and you're following up with all the activities that we're assigning. And let's get going on this. So the first half of the sedimentary rock chart in the reference table, we focused on identification through grain size. We looked at big rocks were glued together, were considered conglomerates. Smaller rocks glued together were considered sandstone, all the way down to shale, which was the clay, that was compacted and formed the rock shale. The second half of the chart, if we look at grain size, we can see that all 5 of these rocks are a variation in grains. They have varying grain sizes, from fine to coarse, and from microscopic to very coarse. So the question is, can I name chemically or organically formed rocks by their specific grain size? And the answer there is no, we can't. For this half of the chart, we're going to have to use composition, what the rock is made out of. And a lot of times we can see the difference between them. When we get to the pictures, you'll see what I'm talking about. So let's talk about the terms, crystalline or bioplastic, because those are the 2 types of rocks that we're looking at here. Crystalline or chemically formed sedimentary rocks are going to be evaporated, typically. So as the evaporation process happens, water leaves, and whatever's in the water stays behind. In this case, we're talking about minerals that are in the water, and those minerals are concentrated, and they build up, and they get thicker and thicker and thicker, and they become chunks of rock, now considered sedimentary rock. Bioclastic, we've talked about this word clast before, means particles. We throw the bio in the front of it, and all of a sudden we're talking about living things. So we're talking about particles formed from living things. And we can put the word organically in there and understand that it was alive at one point in time. There are rocks that are considered both. Limestone can be both crystalline and bioclastic. Here we can see this crystalline process happening. We have the evaporites that we've been talking about. The evaporation of the ocean water leaves behind the dissolved materials that are in the water, typically minerals. This happens in places like oceans, and sometimes in lakes, if the water is still enough and warm enough, the evaporation process can take place. The minerals that are there are typically halite, salt, which is salt, gypsum, and other things. And here we get a couple pictures. This is the salt flats in Utah. This was a big, huge, isolated lake that just evaporated, and all the salt was left behind. This is an example of 4 of the rocks off the ESRT, sedimentary rock chart, that we're talking about here. They're the chemically formed ones, crystalline ones. Rock salt, you probably have seen that as you've thrown it onto your driveway to melt some snow and ice. It's the same stuff. Rock gypsum, so this is the mineral gypsum was in the water evaporated and left behind big chunks of gypsum. We call it rock gypsum. And dolostone and limestone, all formed through the same process of evaporation. You can see the 4 rocks here with their different rock symbols off the reference table. In this diagram down here, we can see the pattern for limestone forming. And this entire area, we can assume, was underwater at one point in time, and water had evaporated and left all this layering of limestone behind. And then over time, weathering and erosion took place, and we can see some chemical weathering carving out the sinkholes and caves and stuff through that limestone. Organic sedimentary rocks, or what we call bioplastic rocks, those are the limestones and corals that are going to form a new rock type. Marine organisms use dissolved minerals to form their hard parts or their shells. After they die, the shells sink to the bottom of the seafloor, where they can accumulate into a thick enough layer for an organic sedimentary rock to form. So imagine you have a colony of shelled creatures, maybe scallops, and over time, as they live and die and go through their life process, more and more of those shells start burying and getting stacked at the bottom of the ocean floor. Those shells are going to be cemented together, and we're going to consider that a sedimentary rock. We're going to call that limestone. The cement, as you can see here, is calcite. The reason for that is the shells themselves are made of calcium carbonate, and the main ingredient, calcium carbonate, is calcite. And we can test for that by dripping hydrochloric acid on the mineral, and if it bubbles, we know that it's got acid in it. And remember that back from the mineral unit, that was a main identifier for calcite. So here's a picture. We see some sea life, plants and animals die and fall to the bottom. We can assume these are the scallops that we were talking about before. They get layered and layered and layered. And the calcite, glues all the shells together, and we have a rock. They're very hard, just like what the regular rocks are. The only difference is they're susceptible to acid that will eat away at the glue, the calcite glue that makes them up. So currently, this is a thriving reef underwater, coral reef, and over time, as all things do, they go through their life process, they live and they die, and all of this coral will be buried under more coral, and it'll all turn into a sedimentary rock we call limestone. The other type of organically formed bioclastic sedimentary rock that we know of is called coal. And in this video, we'll watch this real quick. This narrator will show us how coal forms.
Coal is just ancient.
Of course, you can hear it.
Ancient trees, they fell into swamps. They got buried under layers and layers. And after hundreds of millions of years of heat, pressure, and compression, they got compacted into a dense carbon energy source. And the more compacted they got, the more energy density there is in the coal, the more energy you can get per gram or ton of coal.
So
heat, pressure, and
the coal forms from, and I'll just reinstate what he said. The coal forms from layers and layers and layers of dead plant remains from the swamp and trees from above. As they get buried underneath the ground, the organic material, which is carbon based, is compressed, but and very, very, very compressed. Becomes a very thin layer underneath the ground, and what's left is almost pure carbon. We call that coal. So we can dig down into the ground and we can mine this out, and we can use this in factories as a power source, or your barbecue in the backyard. So to reiterate what we've been talking about, the characteristics for sedimentary rocks. When you pick up a rock off the ground, you need to know about all three rock types. And the hints, the things to remember to identify whether or not it's sedimentary, igneous, or metamorphic for sedimentary rocks is if we see compaction and cemented sediments in horizontal layers. If you can see that, it's got to be a sedimentary rock. If you find a fossil in the rock that you're looking at, it has to be a sedimentary rock. Fossils can be plants or animals, could be any kind of life form that was growing, and the remains have been embedded into the rock. That is a sedimentary rock. It's only a sedimentary rock. Cannot be igneous. It's too hot. It would burn. And metamorphic, we'll get there, is too distorted. We won't see any plant remains or animal remains in the rock. And finally, if it's a chemical precipitated rock, which means it's a very large reconstructed version of a mineral, basically. For halite, for rock salt, it's a big chunk of salt that's been reformed. A little harder to identify by the eye, but those are the three main characteristics that make a sedimentary rock what it is. So remember, we started out the whole sedimentary rock chart, sedimentary rock presentation with layering. If you see these layers like you see here in the Grand Canyon, we are dealing with sedimentary rocks. And then obviously if we see fossils, that's another big indicator. We can see fossils of many different varieties of life, from very old pterodactyls to alligators to, these are called trilobites. All of these indicate that these are sedimentary rocks that they're in. Typically shales that they form in that produces the most detail for the fossils. All right, so that ends our sedimentary rock 3-part section. Thanks for listening. Remember to do your CASA learning and Ed puzzle and whatever is assigned, and we'll see you in the next one. Bye-bye.